And we're live again. So today I'm going to be doing the lead code problem. Let me just share my screen. Give me a second. Share my screen. Share. All right. So we're live again. Right. So the today's problem is basically number of ways to split array. Now, what does this question mean? Right. So let's look at that. We'll take this example: 10, 4 minus 8 and 7. We'll paste it over here. Okay, we'll increase the size a bit. Let's make this 18. Right. Where's the right? 10 4 10 4 minus 8 and 7. Right. I can just write that on my own. So 10 4 minus 8 and 7. Now the question is asked. Now the question has a condition basically, and the condition for basically the task is to divide the array or maybe split the array into two parts. The splitting can be done at any point with a constraint. Okay, but there is a constraint. Now, what is the constraint? The sum of the first I plus 1 elements must be greater than or equal to the sum of the last n minus I minus 1 elements, which is the other half basically. And also, you cannot take all the elements in one half, so there must at least be one element both the on both the halves. We have to return the number of valid splits that are possible in nums. Now let's look at the first example: 10 4 minus 8 and 7. There are two splits. Now there are three ways of splitting nums into two non-empty parts. Split nums at index 0. Then the first part is 10 and its sum is 10. The second part is 4 minus 8 and 7. Its sum is 3. Since 10 is greater than or equal to 3, I is equal to 0 is a valid split. This is one way. Second, we can do it at index 1. So we have 10 and 4, which is 14. And the other will become minus 8 and 7, which is minus 1. Again, it is greater. Then we have at index 2. The first part is 10 4 minus 8. And then we have 7. But the sum is 6 less than 7. So it is not a valid split. So the answer is 2. So very simple, right? So basically, the first one we can take is the first one we can do is a split at here, right? At the position. So let's just say I is equal to 0. The split is happening at I is equal to 0. Then we will have 10. And on this side, we will have 4 minus 8, which is minus 4. 7 minus 4 is 3, which is greater than 10. If we take it I is equal to 1, we will have 10 and 4, which is 14. And we will have minus 1, which is again greater. We can have I is equal to 2, which is here. So we will have 10 4 14 minus 8 is 6, but this is less than 7. So this is not possible actually. So only these two are possible. Okay, these two are possible. So the answer will become 2. So we have two. So we have basically two splits possible. The answer is 2. Right. The question is quite clear. The question is simple. Let's take another example: 2310. Let's try to do this on our own. Let's try to do this on our own. Right. So 2 3 1 and then 0. So we'll follow the same method. We'll have I is equal to 0. So we have 2 and then 3 and 1 is 4. This is less, so it's not possible. I is 1. We have 2 and 3 5, which is greater than 1. So this is possible. We have I is equal to 2 2 3 1, which is 6, which is greater than 0. This is also possible. So again, the answer is going to be 2 splits. Okay. Now we'll talk about the brute force approach, then about the optimal approach. Okay, let me just clear this up. All right. Let's talk about the brute force approach. Now, what do you think is the brute force approach? We'll take the first example only: 10, 4, minus 8, and 7. I'll give you okay. So what do you think is the brute force approach here? What we want to do is so when we're iterating through the index, when we are at I is equal to 0, what I want is the sum of the rest of the elements. So we can simply iterate through the rest of the elements. What are the constraints here? So the constraints are 10 raised to the power 5 is this length. Okay. Obviously, we need a good solution big O of n log n or something of that order of big O of n. So the brute force approach is basically we will start off with this element which is 10. We are at 10, and then we will just iterate through the rest of the elements, calculate the sum, and check whether the sum is great or not. So we will calculate this one by one, iterating one by one. We will check 4 minus 8 minus 4 and then 7, which is 3, and then we will check. So this is 10 greater than 3, which is possible. So we'll say this is one split. Then we will have I is equal to 1. Then we will have I is equal to 1. We can simply add this 10 plus 4, which is 14, and then we'll calculate the sum of the rest of the elements. But it is not that difficult to, I believe it is not. So that solution would be, I think, big O of n only. Right? That solution should be big O of n only. No. Okay, so it will be big O of n squared if you think about it, obviously, because we're having a nested for loop. So you'll have a for loop which is going from I is equal to 0 all the way till the end of the array. And then inside of that, you'll have another, right? So you're having a sum already. You will have a sum, you can say, if I call it S1, the sum one, which is going to be, it's going to be simply array of I, okay, which is basically array of 0, for example. So it's going to be 10. And then I'll have another S2, which I have to calculate, which is the sum of the rest of the elements. For this S2 here, you will have another for loop, okay, and you will iterate from j is equal to I plus 1 all the way till n, right? And that will actually give you the sum S2. You can calculate S2 plus is equal to A of I, right? But you can see that the time complexity will be of the order of big O of n squared, right? Very simple to figure that out. So what should we do? As I was saying, it is very simple to observe. You should be able to observe that we have 10, 4, minus 8, 7. When we iterate through this array, when I'm having 10, at the next, I want to calculate this whole thing. Now it is difficult to iterate. We can use prefix sums here. We will use prefix sums indeed. So let us calculate the prefix sum. So this is 10, 14. 14 minus 8 will be 6, and 6 plus 7 will be 13. Okay, so this is the prefix array. Prefix array is this, right? 10, 4, 14 minus 8, 6, and 13. What is the sum of these elements? It will simply be simply 13 minus of 10, which is going to be 3, right? So as simple as that. I need to, if I want to calculate anything, I'll just use this. I'll just subtract this with the last element. I'll get that, right? If I want to calculate the sum of these elements, I'll subtract this with this. I'll get 13 minus 14, which is minus 1, obviously, right? At the next step, I will just add these two. I already have a sum. I'll just add this. I already have the sum 10. I will add 4 to it. And to calculate the rest of the elements, I'll just use this prefix array. Very simple, right? So let's just code it up. Let's create a prefix array. Right, let's just create a prefix array of the length of, okay, so let me just, we'll declare the n is equal to nums dot size, okay, and then I can say vector integer prefix of n plus 1. All right, for integer I is equal to 0, I is less than equal to n, I plus plus, I'm going to say prefix of I is equal to prefix of I minus 1 plus the value of nums of I minus 1. So this is my way of creating the prefix array. The prefix 0 actually contains a 0 itself, and my actual prefix array is starting from the index 1, right? So that's how I like to have it. It just helps sometimes to return some values or something, right? Just to add the value. So that's how I do it. So now that we have created the prefix array, we will iterate through the nums. So we'll say I is 0, I is less than n, I plus plus, and as we said, so we can have a value which is, I can say integer sum. I can call it integer sum left, which is initially 0, and I can say sum left plus is equal to sum left plus is equal to the current value, which is nums of I. Then I can calculate sum right. Now the sum right will be calculated here only, and this will be equal to the value of prefix of, okay, it should be equal to prefix of last value is going to be n minus prefix of I, if I'm not wrong. If the value of sum left is greater than or equal to sum right, we'll say you can have an answer variable or count variable or anything, right? So this is answer is 0. Sum left is greater than sum right, we'll say answer plus plus. Just simply return the answer. Okay. Let's run this. Okay, it is giving me addition of unsigned offset. Okay, I've made a mistake somewhere. Integer n, integer nums. Okay, man, this is I1. Okay, so I'm getting a wrong answer. It is 3 and 2. Okay. Probably I feel I might be wrong here again. But I'll just try to get the array so that I can see what values I need to subtract. So I'll say for auto and %x prefix here. X. Okay, this is going to be my output. So my output is 0, 10, 14, 6, and 13. And I'm saying the value of sum left is nums of I. Nums of I is equal to 10. So the answer is 10. So the value is 10. Sum right is equal to prefix of n. So prefix of n is going to be prefix of n, which is prefix of 1, 2, 3, 4. 0, 1, 2, 3, 4, which is 13, exactly that we want. I is equal to 0. And it should be prefix of, I should be subtracting 10, not 0 actually. This should be prefix of I plus 1, because 0 is 0, right? So still a wrong answer. Something wrong. That is not possible. So the sum left is greater than equal to sum right. Greater than equal to sum of the last n minus 1 element. So prefix of n, which is 13, minus prefix of I plus 1, which is prefix of I plus 1. I cannot make a split. I think at the end I'm making a split. Am I making a split at this last point? 0, 1, 2, 3. So 0. So we have 0, 1, 2, and 3, right? Yeah, we cannot make a split at this. Should be n minus 1, 2. Or you can say less than equal to n. So we submit this. And we get a runtime error. Oh my god, I passed 97 out of 104 cases. Okay. Okay, I still get a runtime error. Okay, I'm still getting a runtime error. Are the values too big? Are the values too big? Oh my god. Huge test case, I see. Okay, that's a huge test case, but the problem is, where did I go wrong? Where did I actually go wrong? Somewhere here. Why is it underlining that? Okay, sign integer overflow, nothing else. I can simply say this as long n is to the power 5. I'll just call this a day. Should be able to run this. Use test case. Should be able to run this. I probably have to put that as long as well. This is going to be long. Any other thing long. Probably would. That's taking a lot of time for 15 milliseconds. Am I still doing something wrong? Okay. Why is my time so low? I'm doing it way faster than I think I am. I'm just taking big O of n time. Big O of n time is being taken here to calculate the prefix sum, and then big O of n time is being taken here to just compare the values. Why is it so low? Time complexity is big O of n, no? Okay. Okay. I didn't even use this. I didn't even use this. Never mind. The time complexity is big O of n. Why is it not working? Why is it not working? Is it because of maybe I'm just printing the values? Maybe. Let me just sum it again. Okay, still better. But obviously 6 seconds. Obviously I was printing all the values, that's why it took a lot of time. But I still think could have been better. I don't understand what is wrong. Keep track of sum of elements on the left and right. Initially all the elements are on right side. Try each possible split position. Move current elements from right to left side. Check if this creates a valid split. Wait. Keep track of sum of elements on the left and right side. So long, left sum, right sum. Current nums, right sum is plus is equal to num. Initially all elements are on the right side. Oh, okay. This is great. All right. This is nice. I mean, I didn't even think of that. Oh my god. Okay. This is a better solution. Such a better solution. 10, 4, minus 4, 8, and 7, right? So, okay, look at this. So basically we have 10, 4, minus 8, and 7, right? Now what we're doing is we want to create a split, right? And at each split position, we are calculating the sum of the left and right. What we can do is initially we can say the right sum. Okay, this is actually initially this is equal to 10 plus 4 plus we can say this is equal to 10 plus 4, which is 14, minus 8, 6, and plus 7, which is 13. Okay, now what we will do is simply left sum will be equal to the value of left sum. As I can guess, they have just said left sum plus is equal to num side, right? So for the left sum, we'll say this is equal to 10. For the right sum, we'll say this is equal to right sum minus the current value, which is 10. So that will be equal to 13 minus 10, which is 3. Okay. Now the right sum is equal to 3. What will happen the next time is, next time it will again subtract the value 4. So when it subtracts 4, it will become minus 1. Okay. It subtracts the value. So the right sum becomes 3. Okay. The right sum becomes 3, and it will say, okay, the values, right sum becomes 3. It will the next time we are having this 4, we are at this position 4, we will subtract 4 from 3, so we'll get minus 1. The next time we'll say minus 1 plus 8, okay, because we're subtracting, so it will become 7. The next time it will become, wait a minute, minus 1 minus 8. Shouldn't it be minus 9? Wait a minute, what am I getting wrong? Okay, right sum is equal to 3 minus 4 minus 1. Next time again we'll say right sum is equal to, we're just removing, right? Right. So we're actually removing. So we have to say minus 1. Obviously, as I was saying, it will be minus 1 and we're subtracting. So it will become 8 minus 1, which is 7. But it's not 7. No, wait a minute. This whole thing is, maybe I've just calculated 10, 4, 16 minus, okay. Now 10, 4, 14 minus 8 is 6, right? 6 plus 7 is 13. Cool. 10. It should work, right? 13. If I remove 10 from 13, I get 3. If I remove 10 from 13, I get 3, which is Exactly 7 minus 4, 3. If I remove 4 from 3, if I remove 4 from the sum 3, but that is actually different, no? That is actually different. It should not be. I mean, this actually is minus 1 only. We're removing 4 from 3, so 3 minus 1 minus 4, it is actually minus 1. This is working, right? This actually works, which is minus 1. And okay, cool. It is working. I just thought why it is not working. Minus 1 and 7. Okay, cool, right? It's working. I love this method. I mean, I'm going to code this up quickly. This is so nice. Just keep this and I'm going to code this up. No need to calculate prefix sum. I mean, on the other hand, I was thinking prefix sum is really cool. That it is saving my so much of my time, but I didn't think there's a better way. There's a better way possible, right? So I'm gonna say long. This is going to be long. Right sum. Okay. So I'll call this is equal to 0 for auto ampersand x nonce. Right sum plus is equal to x for integer I is 0, I is less than I plus plus. I can say I can declare the integer left sum is equal to 0. I can say left sum plus is equal to, like, left sum plus is equal to the left sum value plus is equal to nums of I. Okay, this is simple. And the right sum, very interestingly, is equal to minus of nums of I if the value of left sum is greater than or equal to the value of right sum. Then we're going to say clear this answer 0, answer plus, and then I'm simply going to select an answer, right? Let's run this. Okay, wait, I have to say this is long. Wait a minute. Wrong. Okay, wait, wrong. I'm sorry. Again, this is minus 1. Only till n minus 1th element, since we cannot split at after last index. Okay, right. So this is the ever since I was a kid, I'm gonna say if I was you, I could have marvelous. Body, yo. Okay, man, this was a nice question. It was a great question. Nice, good. I mean, 100% time complexity, 62%. I mean, great. Cool, right? So we are done with this 2270, right? So we're done with this right away. Prefix sum was actually prefix sum was not a better approach. So this is big O of n squared. I'll just mark it here. Right? Big O of n squared with the highlighter, right? Then you have prefix sums, which is prefix sum big O of n, okay, and then most optimal is also like big O of n faster, little faster, right? Just little faster. So write some calculates. This is nice again. Right. Okay, so let's do this. I'm gonna close this now. Right now. This is right. 2270. Okay, let's close this. So that was all for today. I hope you guys enjoyed the stream. I'll see you soon next time. Stay healthy, keep coding.